Okay, so we're going to be doing some examples regarding the calculation for the average value of a function. So first, please recall the formula for an average value of a function. So basically you need to take an integral, but you've got this extra part with the 1 over b minus a. So be sure to write down that formula because we're going to be using it a lot on the next examples. So here's an example of a problem that you could be asked to solve. You need to find the average value of a particular function on a particular interval. In this case, our function is 1 plus x squared, and our interval is from -1 to 2. So don't forget that that interval means that you've got your a and your b. Actually, that's the closed interval. A comma b. So in this case, your a is -1 and your b is 2. So our average value calculation is 1 over b minus a from a to b of the integral of our function. So that's the formula that we're working with, and now we just need to go on to the actual calculation of values. So our b is 2 and our a in this case is -1. So the 1 over b minus a part looks like that. We're taking an integral from -1 to 2. Our function this time is 1 plus x squared. And we're just integrating that with respect to x. Now 1 over 2 minus minus 1 is of course just 1/3. We'll multiply by that 1/3 at the end. So first we've got to integrate. If you take 1 and do its antiderivative is x, because if you took the derivative of x, you'd get 1 as an answer. And to get x squared as an answer, when you do a derivative, you need to have 1/3 x cubed. So that means that the antiderivative of x squared is x cubed over 3. And again, we're evaluating from -1 to 2. That means that we plug in the top number, 2, and subtract what we get when we plug in the bottom number, -1. And then later we'll multiply this by the 1 over b minus a part, which is 1/3. So we've got 2 plus 2 cubed over 3 minus -1 plus -1 cubed over 3. Now from here, I'm going to finish this calculation. I urge you to try to work along with me. If I'm going too fast, feel free to pause this video at any time and see if you can catch up. Alternatively, you could pause the video and then just see if you get the same answer as me. That would provide good practice as well. But nevertheless, here we go. So we've got 1/3. 2 plus 2 cubed is 2 times 2 times 2, so that's 8 over 3. Now with this part, we need to be careful about the minus sign. So we've got a -1. Now, -1 cubed, that's -1 times -1 times -1. So the result is a -1. And of course, you still have the 3 in the denominator. Now this part here, if you do -1 minus 1/3 is -4/3. So here we've really got 2 plus 8/3. And then you've got a minus 4/3, so that's actually going to become plus, right? All right, nearing the end, we've got 1/3. 2 plus, now here we've got to add the fractions, keep the common denominator common, and add the numerators. 8 plus 4 is 12. So we've got 2 plus 12 over 3, luckily is 4. So this is 6. 6 times 1/3, final answer is just 2. So the average value of this particular function is just the constant 2. Now we know that 1 plus x squared, that's just the typical parabola centered at the origin, yet shifted up 1. If we go from 2 to, or -1 up to 2, the function looks like this. The average value of this function is 2. So that's sort of a visual of what it looks like. Let's look at another one. So this time we're looking at the average value of f of x equals square root of x, and this time we're going from 0 up to 3. Remember the formula, average value of the function, 1 over b minus a, integral from a to b of f of x dx. So from there, in this case, our a is 0 and our b is 3. So this is 1 over 3 minus 0. Right? Because we're on the interval 0 to 3, which means that a is 0, b is 3. We're integrating from 0 to 3, and our f of x dx. So this is really just 1/3. And we do need to integrate the square root of x. The easiest way to do that is to rewrite it in its alternative form, x to the 1/2. Remember, we have not taken the antiderivative yet. We have simply rewritten the value. Now what we can do is take the antiderivative. You know, we need to add 1 to the exponent. Adding 1 is really like adding 2 over 2. So 1/2 plus 2 over 2, that's 3/2. And then remember that you divide by the constant. We do need to evaluate that from 0 up to 3. You can write this as, of course, you can flip and multiply the denominator. Dividing by a fraction is the same thing as flip and multiply. And then you've got 3 to the 3/2 minus 0. to the 3/2. Of course, the 0 you don't need. The 2's cancel. Oh, oops. This was a 1/3, not a 2. That's a messy handwriting. So this is 2/9. Times 3 to the 3/2. And some people may just leave the answer like this. If you do need to simplify for any reason, remember that the 2 means, in the denominator, means square root, and the 3 up here means that you cube. 3 cubed is, of course, 3 times 3 times 3, which is 27. So 3 to the 3/2 is the square root of 27. And like we said, 27 is 3 times 3 times 3. Now remember, when you're doing a square root, pairs come out. That last 3 has no friend, so it has to stay underneath. So 3 to the 3/2 is really 3 times the square root of 3. So if you needed to simplify this further, you could write it as 2/9 times 3 root 3, which would be 2/3 root 3. Again, that's only if you needed to write it as a simplified root. Now, f of x equals square root of x, that's one of the graphs that you really ought to be able to have memorized. The value that we got, if you punch it into a calculator, it's a little bit more than 1. So this is sort of a visual of what the average value looks like. And that, remember, that's only from 0 to 3. All right, so here's another example. All right, so let's take a look at this example. Remember the formula for the average value of a function, which we've been doing in all these examples. 1 over b minus a, integral from a to b, f of x dx. And of course, in this case, our lower bound on the interval is 0, and the higher bound, our b, is pi. So in order to do this calculation, what we're really doing is 1 over pi minus 0, integral from 0 to pi, of cosine of x to the power 4 times sine of x. Remember, when they write the 4 there, that's the same thing as making it to the 4th. And we got sine of x dx. So in order to solve this one, we're going to need a u substitution. So if you let u be cosine of x, then of course the derivative of u with respect to x is negative sine of x. And if you multiply by dx on the other side, you get that du is negative sine of x dx. So that means that this is our u, so we get u to the fourth. And this whole part here is almost our du, but you know how there's a negative here, so we need to put that in. We'll put in a negative sign right here to make it negative sine of x, but we'll also have to put a negative sign out on the outside. So this outside part becomes negative 1 over pi. We're taking an integral of u to the fourth, and then du. Now, don't forget that you have to change the bounds as well, and your bounds have to be changed according to what you chose to be your u. So for the bottom one, we need to do cosine of 0, and for the top integrand, we need to do cosine of pi. Well, remember on the unit circle, at the angle 0, you have the point 1 comma 0, and remember cosines first, sines second per these ordered pairs. And then over at the angle pi, the point over here is negative 1 comma 0. So what that means is that cosine of 0 is just the x coordinate, which is 1, and cosine of pi is the x coordinate of the pi angle. The coordinates is going to be negative 1 here. So remember, 0 is the bottom one, so that's what we need to put down here. So cosine of 0 was 1, and cosine of pi is negative 1. So it looks weird to have the smaller number on top, but just go with it. Keep everything the same. So now we need to do u to the fifth over 5, and we're going to evaluate this from 1 to negative 1. And we're almost done. Okay. So this is negative 1 over pi. So negative 1 to the fifth over 5 minus 1 to the fifth over 5. So this is just negative 1/5 minus a fifth. So it's negative 2/5. So negative times negative is a positive, so we get 2 over 5 pi. And that's our answer there. Now let's do one final example. This time we're going to find the average value of the function 4x e to the negative x squared, and our interval this time is 3 to 5. Okay, so this time we've got 1 over 5 minus 3, integrating from 3 to 5 of our function with respect to x. Now for this one, again, we will need to do a u substitution. So it makes sense to make our u x squared, or you could just make it negative x squared. It'll work out either way. The derivative of this u with respect to x is 2x, and if you multiply by that dx on the other side for the du dx, you get 2 dx. Well, so basically what we need to have here we need to have this be a 2 dx. Well, we've got a 4 dx. Two different ways you could think about it. One is you could think about it as writing 4 as 2 and 2 and putting one of the 2's outside and one of the 2's left. We could do that. So 5 minus 3 is also 2. But here, the 4, we're going to split it up. So we're going to put one of those 2's out here. And the other one we'll leave in, if that makes sense. So that actually means this part just becomes 1 easily enough. And then this becomes this 2x dx part. That becomes our du. And here the x squared is our u. So when we rewrite this, we've got e to the negative u du. Now remember, I didn't put my negative with my u, but you could have done that if you wanted to. You would have had to put a minus sign in and out. The last thing I need to do is put the bounds in. Well, remember that you change the bounds according to your u. So 3 squared is 9, because if you do, and if you do the u equals x squared, that's what you get. And for the 5, you do u equals 5 squared, you get 25. So here we're going from 9 to 25. Now at this point, we're almost done.